Question 1. Glycogen phosphorylase action. Which of the following is the initial enzyme that liberates glucose residues from glycogen during fasting in hepatocytes? A. I16-glucosidase, B. Glycogen synthase, C. Glycogen phosphorylase, D. UDP glucose pyrophosphorylase, E. 4-ID-glucanotransferase. Correct answer C. Glycogen phosphorylase. Explanation. Glycogen phosphorylase cleaves OS1,4 glycosidic bonds to release glucose 1-phosphate from linear glycogen chains until it reaches 4 residues from a branch point limit dextrin. A equals acts on branch point later. B equals catalyzes glycogenesis, not glycogenolysis. D equals part of glycogen synthesis, not degradation. E equals moves 3 glucose units from branch to linear chain during debranching. Question 2. Limit dextrin composition. Which of the following best describes a limit dextrin? A glycogen chain that contains only OS1,4 linkages, the end product of glycolysis. C, a glycogen branch with 2 to 4 glucose residues remaining near an OS1,6 bond. D, UDP glucose precursor in glycogenesis. E, the first intermediate of gluconeogenesis. Correct answer C. A glycogen branch with 2 to 4 glucose residues remaining near an OS1,6 bond species. Explanation. Limit dextrins are remnants after glycogen phosphorylase action halts near a branching point. These require debranching enzymes for further breakdown. A equals describes a linear chain, not a limit dextrin. B equals glycolysis ends in pyruvate. D equals true for synthesis, not degradation. E equals pyruvate or oxaloacetate are first gluconeogenic intermediates. Question 3. Enzyme that moves 3 glucose units during debranching. What is the role of 4-ID-glucanotransferase in glycogen breakdown? A. Adds glucose to the glycogen chain using UDP glucose. B. Transfers 3 glucose residues from a branch to the linear chain. C. Cleaves OS1,6 bonds to release free glucose. D. Converts glucose 1P into glucose 6P. E. Degrades glycogen in the lysosome. Correct answer B. Transfers 3 glucose residues from a branch to the linear chain. Explanation. This debranching enzyme transfers 3 of the 4 glucose residues remaining at a branch to a linear chain, enabling full breakdown. Equal glycogen synthase action. C equals 6-glucosidase does this. D phosphoglucomutase. E equals acid maltase, off 1.4 glucosidase. Question 4. Free glucose liberation in glycogenolysis. Which enzyme directly liberates free glucose, not glucose 1-phosphate, from a branch point during glycogen breakdown? A. Glycogen phosphorylase. B. OF1,6 glucosidase. C. UDP glucose pyrophosphorylase. D. Glycogen synthase. E. Phosphoglucomutase. Correct answer. B. alpha-1,6 glucosidase. Explanation. This enzyme cleaves the OF1,6 bond at the branch point to release 1 free glucose molecule, finalizing debranching. A equals releases glucose 1P from OF1,4 bonds. C equals helps in glycogen synthesis. D builds glycogen. E equals converts glucose 1P to glucose 6P. Question 5. Lysosomal glycogen degradation. Which glycogen storage disease is caused by a deficiency in acid OF1,4 glucosidase lysosomal enzyme? A. Von Gierke disease, type 1, B. Pompe disease, type 2, C. Corey disease, type 3, type 4, E. McArdle disease, type. Correct answer B. Pompe disease, type 2. Pompe disease is due to deficiency of acid maltase, lysosomal alpha-1,4 glucosidase, glycogen accumulation in lysosomes, cardiomyopathy, hypotonia, hepatomegaly. A equals glucose 6-phosphatase, C equals debranching enzyme, D equals branching enzyme, E equals muscle glycogen phosphorylase. Question 6. Glucose 6-phosphatase deficiency. A child with hepatomegaly, lactic acidosis, and fasting hypoglycemia likely has a deficiency in which of the following enzymes? A. Glycogen synthase. B. Glycogen phosphorylase. C. Glucose 6-phosphatase D, debranching enzyme. E. UDP glucose pyrophosphorylase. Correct answer C. Glucose 6-phosphatase. Explanation. In von Gierke disease, deficiency of glucose 6-phosphatase prevents the final step of gluconeogenesis glycogenolysis, hypoglycemia, height lactate, uric acid, hepatomegaly. ABB not associated with this presentation. Question 7. Insulin and glycogenesis activation. Insulin activates which of the following to promote glycogen synthesis in hepatocytes? A. Protein kinase A. B. Glycogen phosphorylase kinase. C. Phosphorylase B. D. Protein phosphatase. E. Glucagon receptor. Correct answer D. Protein phosphatase. Explanation: insulin tyrosine kinase receptor activates protein phosphatase, dephosphorylates glycogen synthase, activating it, and glycogen phosphorylase, inactivating it, favors glycogenesis. A, B, C, E, part of glucagon epinephrine pathways that promote glycogenolysis. Question 8. UDP glucose and glycogenesis. Which enzyme synthesizes UDP glucose, the activated form of glucose for glycogen synthesis? A. Glycogen phosphorylase, glucose pyrophosphorylase. C. Phosphoglucomutase. D. Glucose 6-phosphatase. E. Acid maltase. Correct answer B. UDP glucose pyrophosphorylase. Explanation: converts glucose 1-phosphate plus UTP, UDP glucose plus PPI. UDP glucose is the direct substrate for glycogen synthase, equals degradation enzyme. C equals converts glucose 6P, glucose 1P. D equals final step of glucose release. E equals lysosomal enzyme in Pompe disease.